The following data represents the times measured to 1/10 of a second taken by a number of students to run a certain distance. 12.4, 10.0, 11.1, 9.3, 11.5, 10.7, 11.1, 14.8, 9.3, 12.7, 9.2, 11.1, 10.8, 10.4, 10.7 and 11.9. Part 1. Construct an unordered stem plot to show this data. This can also be called a stem and leaf diagram. The smallest number is 9.2. We have a look in our list. 9.2 is the smallest number. And the largest number is 14.8. 14.8 is the largest number. Thus, the stems will be 9, 10, 11, 12, 13, 14. So, we draw a line across and a line down. And we list our stems on the left of the line. So we have 9, 10, 11, 12, 13, 14. The unordered stem plot is shown on the left, and the ordered stem plot is shown on the right. So for example, 12.4, we go to 12 and we write 4 on the right of the vertical line. For 10.0, we go to 10 and we write 0 on the right of the vertical line. And we continue this until we have our unordered stem and leaf diagram. Next, we just have to order the leaves. So 3, 3, 2 becomes 2, 3, 3. Make sure the smallest numbers are on the left and the largest numbers are on the right. 0, 7, 8, 4, 7 becomes 0, 4, 7, 7, 8, and so on. We leave a blank to the right of 13 because there was no value listed with 13. We do not just forget about 13. It would be incorrect to have 12 and then straight away skip on to 14. It's very important to have a key for a stem and leaf diagram. So the key is seen here at the bottom and it says 11, a vertical line, and 6, which stands for 11.6. And since we have time in seconds written at the top, it's alright to leave it as 11.6, otherwise you would have to write 11.6 seconds. You didn't have to choose 11-6, you could have chose 9-2, 10-0, 10-4, and so on. Or you could choose a value that's not even listed there, so long as you're explaining what it is. Part 3, what time is an outlier? The outlier is 14.8 seconds. We can see that this value, 14.8, is not close to the majority of the rest of the values. So an outlier can either be larger than the majority of the values or smaller than the majority of the values. The percentage scores obtained by the boys and girls of a class on a maths test were recorded as follows. Boys 72, 64, 90, 58, 51, 67, 82, 71, 65, 84, 48, 67. And girls 53, 77, 77, 72, 93, 84, 61, 62, 74, 78, 83 and 72. Part 1. Construct a back-to-back stem plot to show this data. We will order the data as a list before we construct the back-to-back stem plot. So the boys ordered from smallest to largest, and then the girls ordered from smallest to largest. Next we have to see what is the smallest value in our range. So 48 is the smallest value, so our stem will start at 4. And 93 is our largest value, so our stem will go up to 9. So we fill in the rest, 5, 6, 7 and 8. So you can have boys on the left and girls on the right, or vice versa. In this example, the boys are on the left and the girls are on the right. So the value 48 is represented by this 8 here, which is to the left of the 4, so this represents 48. The 51 is represented by this 1, 5, 1, 51. The 58 is represented by this 8, 5, 8, 58, and so on. It's important to note that the smallest numbers are closest to the stem. So for example, in this row here, we have 4, 5, 7, 7. So the 4 is closest to the stem. In this row here, we have 2, 2, 4, 7, 7, 8. So the 2, which is the smallest value, is closest to the stem. And again, make sure that you have a key. So for example, 6-5 stands for 65. Part 2. On quick examination of the back-to-back stem plot, would you consider that the boys had a higher average mark than the girls, and give a reason? On quick examination, it appears as if the girls have a higher average than the boys. This is because the boys' results are clustered around about the 60s. So you can see that there's a lot of boys getting around 60%, while the girls' results are clustered about the 70s. So we can see that the girls have the majority of their scores around the 70s. So on quick examination, the girls have a higher average than the boys.